Hello everyone. Okay, we are going to start in the next 5 minutes by 3:15. So we are going to start. So let's wait for like 5 minutes. Thanks. Hello everyone, you're welcome to this tutorial. In this class, we'll be discussing limits of one variable as well as some properties of some functions. So in the next class, we're going to dive into it properly. So first and first, you can walk towards the door either from inside or outside. So that is an illustration of what limit of a function is. So imagine you are walking towards a door, so you get closer and closer and closer, but you don't touch it yet. So a limit is about what you are getting close to, not necessarily where you land. So take for instance, let's say you have a value, for instance, x equals to, let's say, 3. Okay, so the limit will be as x tends to 3 could either be from the left hand side, that is, you can have something like 2.9. So you can have something like 2.99. So that is from this side. Okay, so you could also have some values from this side. So let's say 3.01, 3.00, 3.01, have 3.001, and so on and so forth. So you are coming from the two sides. So that is what I can really say about the illustration of a limit. So let's say you have another number, let's say 6 for instance. Okay, so the left hand side will be 5.9, 5.99 for instance. So these are the numbers you have on the left hand side as you move towards 6. Okay, and similarly you have the same thing here, 6.01, 6.001. Okay, so let's look into a numerical value of this. Okay, so for instance, let's say we have the limit as x tends to 3 of 2x plus 1. So in this case, we want to find the limit of this function. This is the function here as x tends to 3. So if you plug in 2.99, okay, from the left hand side, so we're going to get 6.8. That is, you have 2 into 2.99, okay, then add 1. So this will give you 6.8. So that is what you get. Then if you take another number, let's say, okay, sorry, this should be 2.9. Okay, so let's take the next one. That will be 2.99. Okay, so it will be 2 into 2.99. Okay, then add 1. So this should give you 6.98. 6.98. So that is what you have for this value of x. So if you go to the other side of 3, that is the right hand side, so where x is equals to 3.01 for instance, so you're going to have 2 into 3.01, then add 1, then this will give you this, that is 7.02. And similarly, if you put in 3.001, then add 1, okay, so this will give us 7.002. So what you can see here, as we get closer to 3, the function, that is 2x plus 1, gets closer to 7. So we say the limit is 7. So that is what we say here. Okay, so the formal notation of this is written as the limit, you can write it like this, as x tends towards 3 or approaches 3, okay, of 2x plus 1, so it's equals to 7. So this is how to illustrate it algebraically. So the limit as x approaches 3 of 2x plus 1 is equals to 7. Okay? So let's look into the graph of this function, that is 2x plus 1 as x approaches 3. Okay, so if you look at the graph here, I think I need to change the ink here. Okay, good. So if you look at the x-axis, so as x, approaches 3, so if you look at this very well, so you see that the limit is 7. So that's the y value. And equally, if you check it from the right hand side here, so as x approaches 3, okay, so the limit is also 7. So here, what we can actually take from here is that a limit is what a function gets close to, okay? So let's say the function here is, okay, 2, okay, let's change the color. So here, the function is 2x plus 1, okay? So the limit of this function is what this function 2x plus 1 gets close to as x approaches 3. So that is the definition of a limit. So a limit is what a function gets close to as this x, okay, tends or approaches 3, okay? Then one thing you need to know is that you don't need to reach the point, okay, the actual point. So just get close to the point. Then limit can also exist even if the function isn't defined at that point. So we're going to look into this as we dive into this course. Okay, so let's look into a practice question for you. Now I want you to find the limit of this function x squared and what happens to f of x as x gets closer to 3. Then the third one will be, are we plugging the number in or just getting near it? So just like 3 minutes should be okay for you. Okay, then come in. And please, if you have any question, you can speak to the mic, okay? So it's okay. At any point in time, you can always ask your question. Okay, if you look at this question, what is the limit of f of x equals to x squared? So algebraically, you can write it like this: the limit as x approaches 3 of f of x. So in this case, f of x is x squared. Okay, so what will be the limit? So if you look at the values of x from the left hand side, so we'll be looking into 2.9, 2.99, okay, as you approach 3, and you could as well take some values from the right hand side, say 3.0, 3.001 and the likes, okay. So you'll come to realize that the limit is 4. Okay, so it will be 4. Then what happens to f of x as x gets closer to 3? So f of x gets closer to, sorry, the limit is 9 rather, because you get this, sorry. So f of x moves closer to 9. So it gets closer to 9. Okay? And some people, you may want to use direct substitution. Okay? So that's true. But even if f of 3 wasn't defined, so we can still find the limit by getting close to 3. Okay? So from this, you should know that the limit of any function as the input, x is the input, approaches a given number, okay, so is always the output, that will be the L. So here, the x is the input, so f of x is the function, and the limit, L, is the output. Okay, so this is the illustration, okay, or notation of limit of a function. So the input is always x, what it tends to, okay, and the output is the limit itself. Now we're going to look into some properties of some functions, okay, and from there we can just take a look into an overview of questions and limits, okay, before we dive into it properly in our next session, okay. So here, the first one will be the limit of a constant. So in this case, once you hear the word constant, it means the f of x, the function, is a constant. And how do we denote or illustrate that? So f of x is equals to c. So you can say where c is a constant number. It's a constant number. Okay, good. So if you use that general formula of limit, that is the limit as x approaches a of f of x is equals to L. So now let's substitute the value of f of x, which is the constant now. So it will be equals to, so it implies the limit as x approaches a of c, then it will be equals to c. So this is the first property of a limit. Okay, so the limit of a constant is always the constant. Okay, so let's look into an example. Okay, before then, so don't forget that the x value is the input and the limit is the output. So it means irrespective of what the input is, okay, so the limit of the output is always, the limit of the function is always the constant. So let's look into an example. So let's say you asked to find the limit, okay, as x approaches 3, for instance, of 5, okay. So 5 is the function here, it denotes the function, and the value of x approaches 3, okay. So this is the input, and don't forget, irrespective of what the input is, the output is always the constant, so it will be equals to 5. So that will be the limit of 5 as x approaches 3. So let's look into another property. So this will be limit of the identity. So it means f of s is equals to x, that is, the output will always be the input. If the input is, let's say 3, okay, so the output will also be 3. If the input is 5, the output will also be 5, okay? So that is an identity, okay? So if this is the case, so we can write the limit as x approaches a of the f of x now is the identity, which is x, okay? So to be equals to what the identity is of, okay, x. So this is what you should take note, okay? So this is an identity, and the limit of an identity is what is equal to the input, okay? So for instance, if you have the limit as x approaches, let's say 5, okay, of x now, okay, so what will be this? So the input is 5, okay, so that will be, the limit will be the input, which is 5, okay. So from here, this is the property of the identity, the limit of an identity, so it will be equals to 5. So all these are very important for you, because by the time you are actually solving some questions, so you are finding the limit of a given function, so you will need all these properties, okay, to evaluate the limit. So it's very important you are conversant with them, okay. So let's look into the limit of a sum. So in this case, the f of x will be a kind of, let's say, g of x plus f of x, or f of x plus g of x, okay. So that will be the function now, that is, and this can be another letter, so it's not necessarily f of x, okay. So I think can change this to p, but it doesn't really matter, okay. So the most important thing is that you're having sum of what? You're having sum of two functions, so it could be more than 2, so you could have more, 2 or more functions, okay. So the same logic applies to them, okay. So if you put this into the standard form, okay, so that will be the limit as x approaches a of f of x now. So the f of x will be a sum now, so which you can write as f of x plus g of x, okay. So it will be equals to L. So that is this, and this one can be written as, it will be equals to the limit as x approaches a of f of x, then plus the limit as x approaches a of g of x. So this is the limit of a sum, okay. So you can actually separate them, let the functions have a unique limit, as you have done here, okay, like different limit notation, okay. So let's look into an example. So let's say you have, so let's say you have this, you want to estimate the limit as x approaches 2 of s squared plus 3x, okay. So this is the f of x, okay. So you can write this as the limit as x approaches 2 of x squared, then plus the limit as x approaches 2 of 3x, okay. So you can actually split them into this, okay. So now as x approaches 2, so we can use direct substitution. So this will be 2 to the power of 2 plus 3 into 2. So this will be equals to 4, add 6, and these two add up to 10. So that will be the limit. So the limit as x approaches 2 of x squared plus 3x is equals to 10. So the same thing goes for the difference. Okay, so in this case your f of x will be equals to, let's say, f of x minus g of x. So in that case the limit from the general one as x approaches a, so of f of x to be f of x minus g of x. So you may want to put this square bracket here. Okay, so to tell you that the whole of this represents f of x, it will be equals to L. Okay, so what will be the limit now? So this will be equals to, you can separate them, okay, by writing this now. So it will be the limit as x approaches a, okay, then f of x, then minus the limit as x approaches a of g of x. Okay, similar to that sum. Okay, so let's look into an example. So for instance, you have the limit as x approaches 1 of, let's say, x squared minus 2x. Okay, so this will be equals to what? So you can actually do this. Oh, sorry for that. Okay, so you can actually simplify this by applying the property of difference of two functions. Okay, so this can be written as the limit. So let's give them different notations. The limit as x approaches 1 of x squared minus the limit as x approaches 1 of 2x. Okay, then this will be equals to 1 squared minus 2 into 1. So this will be equals to 1 minus 2, and this will be equals to negative 1. Okay, so please, if you have any question, you can always ask your question. Okay, so we've covered this now, the limits, the properties of a constant, the property of a constant function, identity function, sum, and difference of polynomials. Okay, so let's look into another one. That will be products. So for the products, the f of x in this case will be equals to f of x multiplied by g of x. So if we put this into the standard form of limits, so it will be limit as x approaches a of f of x into g of x. So you may want to put this here, and this will be equals to the limit. Okay, so you can separate them as well. So this will be the limit as x approaches a of f of x, okay, multiplied by the limit as x approaches a of g of x. Okay, so you can do this. Let's look into an instance. So let's say you want to evaluate the limit as x approaches, let's say, 3 of x dot x plus 2. Okay, so I may do something like this. Okay, so this will be equals to what? So we can just do this. So let's apply the property, so we can separate them to be the limit as x approaches 3 of x, then multiply by the limit as x approaches 3 of x plus 2. Okay, so here now, if you key in this value, x will be equals to 3, then multiply by 3. Okay, you want to put this in a bracket, add 2. Okay, so and this will be equals to 5. These two add up to 5. You have 3 multiplied by 5, and the answer is equals to 15. Okay, so the same thing goes for the quotient. So the quotient, the f of x will be equals to f of x into g of x. Okay, so good. So here g of x cannot be 0, so you have to take note of this. Okay, so otherwise it will be undefined. So here we can now substitute this into the standard form of the limit. So in this case it will be the limit as x approaches a. So f of x will be f of x over g of x. Okay, so it should be equals to the limit. Okay, so which implies that the limit as x approaches a of f of x, then everything over the limit as x approaches a of g of x. So for this one too, where the limit as x approaches a of g of x is not equals to 0. Okay, so that is the condition here. Okay, so we can look into an example. Let's say we have the limit. So let's say we have the limit. I want to evaluate the limit as x approaches 2 of x squared minus 1 over x plus 1. Okay, so this is equals to the limit, and it will be equals to the limit as x approaches 2 of x squared minus 1. Okay, so you can use this and you can use the division sign here. Okay, so over the limit as x approaches 2 of x plus 1. So if you substitute this, the value of x to be equals to 2, okay, so don't forget that this can never be equals to 0. So this will give us 2 to the power of 2 minus 1 over 2 add 1. So this will be equals to 4 minus 1 over 3. Okay, and this will be 3 out of 3, and that will be equals to 1. Okay, so now let's look into another one. That will be constant multiple rule. Okay, so please, if you have any question, so please don't hesitate to ask your question. So at any point in time, you can always ask your question. Okay, so for this, you have constant multiple rule. So what do you think? You can type in the comment section. So what do you think the f of s will be for this one? So what do you think? Yeah, so what do you think the f of s will be? Yes, anybody? Okay, so in this case, we have constant multiple. So the f of x, in this case, it will be equals to a constant, okay, multiplied by f of x. Okay, so this is what you're going to have here. Okay, so if you key in this into the standard form of limit, okay, so notation, that will be the limit as x approaches, excuse me, the limit as x approaches a of f of x. So this will be c multiplied by f of x. Okay, so you may want to put this bracket. So this is an entity. Okay, then it's equals to the limit. So this will be equals to, so you can actually take out the constant. So that will be c, then multiplied by the limit as x approaches a of f of x. So let's look into an instance. So let's say we want to evaluate the limit as x approaches 2 of 2 into, let's say 2 into, okay, I think I can write 2 into x, okay, so let's write 5x, okay, 2 into 5x, okay. So if you want to do this, so you can actually take out the constant here, so it will be 5 into the limit as x approaches 2 of x. Okay, so you know already that this is the property of an identity. Okay, so because the input will always be the output, so the limit of this will be equals to 2, right? So in this case, this will be 5 into 2. I think that was the second property we looked into, the limit of an identity. Okay, so an identity function is a function whereby the inputs and the output values are the same. Okay, so what the output will always be what the input is. If the input is 2, then the output will be 2. If the input is 5, then the output will be 5. So that is the simplest explanation. Okay, so and if you look at this one, so this is the input. Okay, so this will be the function, and the output will be this as well. Okay, so x equals to 2, and the final answer here is 10. Okay, so I think that should be about 6 to 7 now, so I'm not counting. So another one will be power rule. So here the f of x will be a kind of, let's say, x to the power of 3. Okay, then here if you key in this into our standard form, that will be the limit as x approaches a of f of x, in this case x to the power of 3. Okay, so it will be equals to L. Okay, so let's say s approaches, okay, sorry, this is an example. Let me just say x to the power of n. Okay, so x to the power of n. Okay, as x approaches a, then it will be equals to limit. Okay, so this will be equals to, you can actually drop this. So if you want to do this, so you can take the limit of this, then raise it to the power of, so it will be the limit of x to the power of 3. So this will be equals to limit as x approaches a of x. Okay, then you can now put everything, or raise everything to the power of n. Okay, so this is what you get here. Okay, so that's the property. So an illustration would be, let's say we want to find the limit. Okay, so I'll still maintain the s cube I wanted to use before. So in this case, as the limit of s cube as x approaches let's say 3, so it will be equals to what? So mind you, so you can read this as the limit of s cube as x approaches 3, or you can say the limit as x approaches 3 of s cube. So you can use any of the two ways. Okay, so this will be equals to the limit as x approaches 3 of x now, okay, then everything raised to the power of 3. Okay, so we can now do this. So once again, this is an identity property again here. So obviously, so everything in the bracket will be equals to 3. Okay, because the output is, the limit is always the input. This is an identity function. Okay, and the property here is a identity property of the limit of a limit. Okay, of a function. So this will be 3 to the power of 3, and this will be equals to 27. So another one will be, let's look into this, I think, roots rule. Okay, so that will be another one. So in this case, is the roots f of s will be equals to a radical like this root. Okay, it can be any other one. Okay, so it will be the limit as x approaches a of x to the power can. Okay, I think you understand it now, so we can just be solving this directly now. So it will be equals to, like, this is just an example we can do directly without writing the illustration. So I think we are used to that already, so no need of writing the illustration. So I think we are good to go. What do you think? Oh, okay, it's okay. Let me just do that, since let me maintain the standard. So it will be the limit as x approaches a of this, that is the x. Okay, then it will be equals to L. So this is the f of x. Then it will be equals to the limit as x approaches a, okay, of x. Then everything will be under this radical. Okay, so that is what you do. So an example will be, so let's scroll down a little bit. An example will be the limits as x approaches, let's say, 9 of root x. Okay, so this will be equals to, so applying this property, okay, it will be limit as x approaches 9 of x, then everything will be under this radical. Okay, so let's scroll down a little bit. Okay, so here, don't forget that this is an identity property again. Okay, so it will be 9. What we have under the radical will be equals to 9. So we're going to have root 9, and the final answer is 3. Okay, so let's look into another one. So in this case, this will be a direct substitution. Okay, so let's say you have a kind of the limits. Let's say you have let's say a polynomial, for instance. The limits of f of a as, sorry, let's take that again. So the limits as x approaches a of f of x, okay, so it will be equals to the limit, okay, and this will be equals to f of a. So this is the direct substitution you can always apply, okay, so as it gives you the result on time. So if you look into an expression, okay, let's say the limit as x approaches, let's say 2 of this polynomial, x squared plus 2x plus 1. Okay, so the answer, okay, of the limit, okay, will be f of 2. Okay, so that is what it's saying. So we have to substitute directly. Okay, so this will be equals to 2 to the power of 2 plus 2 to the 2 into 2 plus 1. Okay, so this will be 4 add 4 add 1, and it will be equals to 9. So that is the direct substitution. Okay, so you should uh, take note of this. These are the properties of polynomials. Okay, so let's look into. You can have the other properties. I think we still have some time. Okay, so let's say you have trigonometric functions, for instance. Now, so how do you get the limit? Okay, so let's just take this. Okay, so for instance, if you have that is the limit, the f of x in this case is sine x over sine x over x, for instance. Okay, so what would be the limit if f of x equals to this? So for this one, if it tends to 0, okay, that is a is equals to 0. So if you have a general form, the limit as x approaches a of f of x is equals to the limit, okay. So this is the f of x now, and a is equals to 0 for this one. So that is the limit as x approaches 0 of sine x over x, okay. So it will be equals to a standard, okay, 1. Okay, so this is what you should take note. So this is a standard property, okay, for a trigonometric function. So please let's take note of this. Okay, so we can scroll down and look into another one, still under trigonometry. I think we can look into two more examples. So the same thing, if you have the limit of x, the limit as x approaches 0 again of tan x over x, so the answer will also be equals to 1. Okay, so please take note of this. And similarly, or lastly, if you have the limits as x approaches 0 or tends to 0, and the f of x is 1 minus cos x over x squared. Okay, so let's say this is a whole identity. Okay, so you can use identity from trigonometric functions. Okay, so to prove this, so that is trig limits often use identities. Okay, so or Los Peter's rule, something like that. Okay, but the most important thing is for you to just get this. Okay, so this will be equals to 1 out of 2. Okay, so in summary, for trigonometry functions, okay, if you have the limit as x approaches 0 of sine x over x, it will be equals to 1. So similarly, the limit as x approaches 0 of tan x over x, it will also be equals to 1. So this is the first one, the second one, and the third one is the limit as x approaches 0 of 1 minus cos x over x squared. So it should be equals to a half. So these are the three properties under trigonometric functions you should take note. Okay, so let's look into logarithmic functions. Okay, so let's say you have limits as x approaches 0, okay, of ln x. Okay, so it will be equals to negative infinity. Okay, so please take note of this one. Then the second one, the limit as x approaches infinity, okay, still len x, okay, so it will be equals to positive infinity. Okay, then the third one, so let's scroll down a little bit. If you have the limit, now we want to look into 1 when x tends to 1, and after this we look into x tends to 0. Okay, then of len x over x minus 1. Okay, so this will be equals to 1. And the fourth one is limit as x approaches 0 of len 1 plus x, okay, over x. It will also be equals to 1. Okay, so this is just the summary of the 4 properties we have under logarithmic functions. Okay, so the limit as x approaches 0 of len x will be negative infinity. The limit as x approaches infinity of len s, so it will be positive infinity. And the limit as x approaches 1 of len x divided by x minus 1, then it will be 1. And finally, the limit as x tends to 0 of len 1 plus x over s is equals to 1. Okay, so let's look into let's say exponential function. So you have the limit as x approaches infinity of exponential x. Okay, so the limit will be equals to infinity. Okay, then that's positive infinity. So we can also have another one, the limit as x approaches negative infinity, for instance, still exponential x to be equals to 0. So there's the first one, the second one, then the third one will be the limit as x approaches 0 exponential x minus 1 over x. Okay, so this will be equals to 1. And finally, I have the fourth one. So I think I can manage the space here. The fourth one, the limit as x approaches infinity, then you have x over exponential x, then it will be equals to 0. Okay, so let's take note of this. So these are very easy to recall. Okay, so if you plug in this, you get infinity. So negative infinity will give you 0, and this, if you plug in x, you get 1. Okay, and this will also give you this. Okay, so let's look into the last one. Okay, and that will be the end for now. So it will be radical functions like square root, cube root, if you have something like that. So let's say you have the limit as x approaches a, okay, of root x, for instance. So it will just be root a. So this is pretty straightforward. So, but it has a condition: if and only if a is greater than or equals to 0. So it must be a positive number, otherwise there will be a problem here. So you cannot have a negative number here. So x cannot be negative, okay, it must be positive. So that is the implication. Okay, so or if you want to generalize this, so you can say the limit, okay, as x approaches a of the n roots of x, okay, so it will be equals to the n root of a, okay, so this we cannot put the condition here, okay, so because if you have odd functions, okay, if x is odd, so it allows a negative number, so it will work. Okay, but for even functions, okay, so you have to put this condition, that is, if and only if a is greater than or equals to 0. Okay, so I think I can just do this. So if a is greater than or equals to 0, so this is for even, okay, function. For odd, so for odd, negative numbers, okay, or negative values of a, okay, are allowed. So there's no problem, just for you to take note of that. So guys, I think this is where we'll be stopping for today. So until we meet again, so we can always dive into some practical examples. So now you are aware of the whole properties for the polynomials. I think I talked about 9 of them. Then we also looked into uh, basic or standard properties of logarithmic functions, trigonometric functions, exponential functions, and the radicals like this. Okay, so you just have to take your time to study them and be used to them. So in the next class, that will be looking into different, will be evaluating limits of different functions. So all these properties will be very useful. So it's very good for you to know them for now. So until then, stay safe and be good.